This is the 8-3 lesson quiz. Let's start with number 1. This is all about quadratic functions in standard form. It says, what is the vertex for f of x equals x squared plus 4x plus 6? So in order to solve this, we're going to use our formula of x equals negative b over 2a. This formula not only gives us the axis of symmetry, but it's also going to give us the x value of our vertex. So we're going to come over to our equation and we're going to label our a, b, and c. So a is always the number in front of x squared, which is 1. B is always the number in front of x, which is 4. And c is always the number that's on its own, which is 6. For this specific formula, we just need a and b. So we're going to write x equals the opposite of b. So b is 4, so the opposite is negative 4. On the bottom, we're going to do 2, because that's part of our formula, times whatever a is, which is 1. When I simplify this, I get negative 4 over 2, or negative 2. So I know the x value of my vertex is negative 2. So I'm going to come up here and put in negative 2. In order to find the y value, I'm going to take my equation. So f of x equals x squared plus 4x plus 6. I'm going to take out the x and I'm going to replace it with negative 2. So f of x equals negative 2 squared plus 4 times negative 2 plus 6. Make sure anytime you take out a letter or a variable from your equation that you replace it with parentheses around your number. So let's go ahead and simplify using order of operations. Start with my exponent, negative 2 squared would be positive 4. Move on to multiplication, 4 times negative 2 is going to be negative 8. And then plus 6, and I'm going to work left to right for addition and subtraction. 4 minus 8 is negative 4, and negative 4 plus 6 would be 2. So f of x equals 2. So my vertex is going to be 2, 2, which is letter B. Moving on to number 2, they tell us that a ball is thrown into the air. The height h in feet of the ball after x seconds is given by this function. What is the equation in standard form, and what is the maximum height of the ball? So first, we're going to put this into standard form. Right now, it's in vertex form. In order to put it into standard form, it needs to look like f of x equals ax squared plus bx plus c. Now, sometimes this f of x over here will look a little bit different. You can also use letter y, or you can put other letters with your function. So really what we're focusing on is this ax squared plus bx plus c. So I'm going to take my function, h equals negative 16 in parentheses x minus 2 squared plus 72. And I'm going to simplify this, meaning I'm going to get rid of this exponent. So what will happen is I'm going to need to do 8x minus 2 squared, which is the same as x minus 2 times x minus 2. You can multiply this out and get x squared minus 2x plus 4, which then simplifies to x squared minus 4x plus 4. So I'm going to come back over to my equation, h equals negative 16, but now instead of having x minus 2 squared, it's going to say x squared minus 4x plus 4 plus 72. I'm going to distribute that negative, so it's going to say h equals negative 16x squared. Then I'm going to do negative 16 times 4, which is going to be 64. X, and then again, negative 16, but now times positive 4 would be minus 64. And then I still have that plus 72 at the end. So when I do negative 64 and positive 72, that's going to give me an 8 at the end. So my equation is h equals negative 16x squared plus 64x plus 8. Now, they also give me a second equation. Based off of my answer, I know it's going to be letter D, but I also want to point out to you how you're going to find the maximum height of the ball. The maximum height, because this is a parabola opening down, since it leads with a negative, our vertex is our maximum. And when you have an ordered pair as your vertex, the x value is always going to be your axis of symmetry, and the y value is going to be your maximum. You can either use negative b over 2a and solve for your vertex like we did in number 1, or because we have vertex form, we can look at that equation and our vertex is going to be the opposite of what's inside the parentheses, so positive 2, and then exactly what's on the outside, which is 72. Our y value is 72, so that would be the maximum height. For number 3, we're going to graph the function, and we're going to find the axis of symmetry, the vertex, and the y-intercept. So looking at our equation, we have f of x equals 0.5 x squared minus 2x minus 2. They want us to find the axis of symmetry, so we're going to use our formula, x equals negative b over 2a. So let's see, a is 0.5, b is negative 2, and c is also negative 2. So when I plug this in, x equals the opposite of b would be 2. And then on the bottom, 2a would be 2 times 0.5. Well, 2 times 0.5 would be 1. So it's 2 over 1 or just 2 as my x value. So my axis of symmetry is going to be x equals 2. And let me write that down. So x equals 2. And I know half of my vertex is going to be 2. We're just going to have to find the other half by plugging it in. So f of x equals 0.5. And then 2 goes in parentheses squared, minus 2 times 2, and then minus 2 again. So 2 squared is 4, and half of 4 is 2. Negative 2 times 2 is negative 4, and then another minus 2. 2 minus 4 is negative 2. Negative 2 minus negative 2 would be negative 4. So my vertex is going to be 2, negative 4. And your y-intercept is always the number all the way at the end, which is the number, it's going to be c, the number all by itself. So in this case, the number all by itself is negative 2. So when I go to graph this, I have my axis of symmetry, which is going to be at x equals 2. So this red line represents my axis of symmetry. Then I'm going to have my vertex at 2, negative 4, which is right here. And let me make a better dot. There we go. And then my y-intercept is at negative 2. And right away, what I can do is that's 2 spaces to the left of my axis of symmetry. So the same height would be 2 spaces to the right, which is right here. We can always find another point by plugging in any value. So if you think about it right now, our x and y's. So we have our vertex, which is 2, negative 4. We have 0, negative 2, and then we also have, that would be 4, negative 2. And so I'm going to plug in 1 to see what that value would be so that I can have 5 points for my parabola. So if I go back over to my equation, it would be 0.5, and then 1 squared minus 2 times 1 minus 2 again. 1 squared is 1 times 0.5 is 0.5. Negative 2 times 1 is negative 2, and then another negative 2. So 0.5 minus 2 is negative 1.5, and then minus 2 again is negative 3.5. So this is going to be 1, negative 3.5, and 3, negative 3.5. So it's going to be somewhere around here. And when I go to draw my parabola, it's going to be opening up because my leading coefficient is positive. So here's my graph. We found the axis of symmetry, the vertex, and the y-intercept. Let's move on to number 4. In number 4, we have 2 different functions, and they want to know all the things that are true. And so first off, they ask us for letter A, the vertex of the graph of function g is above the vertex of the graph of function f. Well, let's find out our vertex. So we've got g of x up here, which is x squared minus 4x plus 3. And then we'll do f of x down here, which is x squared minus 4x. So we're going to use negative, or x equals negative b over 2a. So negative b, the opposite of b, if b is -4, the opposite is +4, times 2 times a is going to be the number in front of x squared, which is 1. So our x value is 2. And when we plug that into our equation, g of x equals 2 squared minus 4 times 2 plus 3, we'll get 4 minus 8 plus 3. 4 minus 8 is -4, plus 3 would be -1. So here's our first vertex. For f of x, we're going to do the same thing. The opposite of b is 4 over 2 times 1 would be 2. And then we're going to plug in 2. So f of x equals 2 squared minus 4 times 2. 4 minus 8 would be -4. So this vertex is 2, -4. So they're saying the vertex of the graph of G is above F. So they're saying G is going to be above F, which is going to be true because if we had a graph, they both have an X value of 2, but now when we go to graph G, it's going to go down 1 space, which would be about here, and go up. And if we were to do F, we would be down here and go up. So this is the G graph, this is the F graph. And since they're saying G is above, letter A would be true. The graphs have the same axis of symmetry. That's also true because they both have X equals 2. So B is correct. Function F has a maximum and G has a minimum. That's not true because they're both opening up. So they're both going to have a minimum. So letter C is not right. Letter D, the graphs never intersect. Because these graphs are located on different spots, you can see that G is directly above F. As G is expanding, it looks like it would intersect, but F is also expanding at the same time. So these will never intersect. They're going to always be separated. As one's increasing, so is the other one. So they will not intersect. And then letter E says that they have the same y-intercept. Well, the y-intercept is always going to be the number at the end. So if you look, oh, I'm sorry, D, I should have put yes, D is true. They will never intersect. So let me fill that bubble in. And the same y-intercept, well, function G has a y-intercept of 3 because that's the last number. F doesn't have a number at the end, so that would be represented by 0. So they do not have the same y-intercept. Let's move on to number 5 now. In number 5, it says that we have this function y equals 2x squared plus bx plus c, and they want to know the values for b and c. Well, if you look at your graph, we know that the vertex is going to be 3, -10. So we should be able to find our b by doing our axis of symmetry. X equals -b over 2a. We know our x value is 3. We don't know what b is, but we know that a is 2. So when we plug this in, we get 3 equals -b over 4. We're going to multiply both sides by 4 and get 12 equals -b. So positive b is -12. So that's our first value. When we can continue to use this information by plugging in, I'm going to take out this b right here, and I'm going to plug in -12. From here, we're going to be able to solve for c using the same idea, using our vertex. But this time we're going to plug in x equals 3, and we're going to solve for y equaling -10. So our equation is going to look like -10 plus 2. I'm sorry, not plus. Let's try that again. We're going to write equals 2 in parentheses, 3 squared minus 12 times 3 plus c. We're going to simplify this and solve for c. 3 squared is 9 times 2 is 18. -12 times 3 is going to be -36. And then we have plus c. When I solve for this, I get -10 equals -18 plus c. So c equals +8. So b is -12 and c is +8. You are all set for your 8-3 quiz.